Hey there, class. So we're just going to go through lesson 4 right now. Lesson 4 is the second part to the transformations of sine and cosine. So we're just continuing on from lesson 3. In lesson 3, we went from the equation to the graph. Sorry. We went from the equation to the graph. Now we're going to do the opposite. We're actually going to go from a graph. So we're going to know what the graph looks like to an equation. And you haven't really done this year, but you've done it before for sure. When we did line, so y equals mx plus b, you used to have to find the line, and then you would find the equation of the graph using the line by finding the slope from the line using 2 points, using the y-intercept, whatever it might be, to find the equation of that line. This isn't any much different. What we're going to be doing now is we're going to actually be using our sinusoidal function in order to determine the parameters of the graph, right? And then once we find the parameters of the graph, we can actually determine the equation, because then it's just about plugging things in, right? And then we're going to figure out how different properties of the function, how we can determine different properties of the function by looking at the graph. So we're going to be able to find the amplitude by looking at the graph. We're going to be able to find the period by looking at the graph. You're going to be able to, and then you're going to use that in order to find your K, A, D, and C values. So you should also be able to determine the phase shift. We've kind of already done this in lesson 1, where we looked at a graph and I said, okay, the amplitude is blah, period is this long. So we're going to be going back to that lesson. So in this first section, what I'm going to go over with you is how to determine the equation of a sine or cosine function given its graph. So there's 6 simple steps. The first thing you're going to do is you're going to go here to this graph and you're going to go determine what the max and what the min are, right? So here we determine what the max and the min are. Then you're going to find the amplitude. You're going to do max minus min divided by 2, find the amplitude. That amplitude is also your A value. So easy to remember, amplitude is your A value, right? So you're just going to plug that in for A. So what I like to do is I like to make a little A, K, C, D chart on the side, and then I just go plug in and fill it in as I go, right? So amplitude is A. Then you're going to go ahead and you're going to find your C value. So I'm just going to go here and I'm going to write that down. So A equals amplitude, right? C is your axis, right? So that's your vertical shift, right? So that's really easy. What we do to find axis is going to either be you take the max minus the amplitude. That helps you find the middle of a function. Or you can do the normal formula that we were doing before, max plus min divided by 2. Both of these will get you your axis. Just sometimes you don't have the min, you only get the max value. So you can do max minus amplitude in order to get that. Then you are going to go find your K value. Your K value is also 360 divided by your period. And that's because, remember when we were doing yesterday's lesson, in order to find the period, we would just do 360 divided by K. If you rearrange the formula, you get K divided by, K equals 360 divided by K. So you'll see right here, that conversion, right? So you find how long one cycle is, find the period, divide that by 360 divided by K will give you your period. And then the last thing we're going to find is the phase shift. And this is actually the part that seems to mess people up the most. So remember when I said sine and cosine are both functions of each other, right? So sine is just a horizontal shift to the left by one interval of cosine, right? And cosine is the shift of sine to the, so cosine is the shift of sine to the left, right? And then sine is just, if you shift it, so if you shift cosine over by one interval, you get sine, right? So for sine x, trace along the center line and find the distance between the y-axis and the bottom left closest rising to the midline. So if you find the axis, just go and find the closest point there is to 0. So in this situation, it was this one. Go up. This is one of our circles. Same thing here. Go find the closest x distance between the y-axis. That's the maximum point. So the closest to the axis for sine and the closest to the y-axis for the closest max to the y-axis for cosine. Let me repeat that. So you're going to go find the closest x value that is on the axis to the y-axis, And then for cos x, you're going to go find the closest maximum point to the y-axis. Okay? So then what you're going to do is, I'm going to actually just walk us through how to do this. So the first section I was just showing you kind of the steps. We're actually going to apply those, right? So the first thing we're going to do to find our max and min of this function, I'm just going to go, max is 3, the min is -1, right? So now I have max and I have the min, right? Easy peasy. Then what I'm going to do is I have the max, I have the min. Let's go ahead here and find the amplitude. So the amplitude is equal to max minus min divided by 2. So I'm going to do 3 minus -1 divided by 2, which is going to give me 2. Right? 4 divided by 2 is 2. So my a value, I'm just going to write it here, a is equal to 2. Then my second step here is going to be to find the vertical shift, right, or my axis. I can do this one of two ways. I can take max plus min divided by 2, or I can just do the max value, which is 3, right? So I'm just going to write that in. So C equals max minus amp, right? I don't really care how you do it. They're both accurate. Just sometimes you can't do it the other way because you only have the max value. So max minus amplitude, so that's going to be 3 minus 2 is equal to 1. So that means that my axis is right here at 1. Okay? So that's my axis. So now I have my C value. I'm just going to go write that in. C value equals 1. Right? Then I'm going to go find my K value. Like we said, K is equal to 360 divided by period. So let's go trace one of these. This is the cosine function, goes down, goes up, and then see how it's starting again. So now I have a period of 10, right? So my period is 10, so I'm just going to do 360 divided by 10 is equal to 36. So my K value is 36. Now, this is where it gets a little bit tricky. So if I'm looking at this function right now, it is very obviously a cosine function, right? There's no horizontal shift. It starts at the max. This is very obviously a cosine function. So I'm just going to go ahead. That means that I have no d value. D cosine is equal to 0, right? Because it starts at the max. This is my d cos. But I do have a d value for sine. And the d value for sine is the closest point on the graph that's at the axis that starts off the sine function. So even though technically this is the closest point on the x-axis, it doesn't start off the sine function, it's on the downwards trend. So then I'm just going to go follow that line until I get to the point where it's closest start point for sine. So this is my distance for sine. Go up, come down, right? One thing to notice is the A, K, and D value, the A, K, and C values stay the same for any cosine and sine function. So you can still use 2, 1, and 36. The only thing that's changing here is the D value, right? So our D for cos is 0, but our D for sine, if we're looking at it as a sine function, is going to be, that's like, I know that looks, it's about 7.5, right? So D value is 7.5, right? And that's because each turn of the graph is about, we go up by 4s every time, right? We go up, there's 4 turns in this graph. So if we did 10 divided by 4, we would get like 2.5, right? So if we, we get, 2.5. So if we did 10 minus 2.5, we get 7.5. Okay? So we have d sine is 7.5. And we'll talk more about that when we start lesson 5. Okay? So then we have our d sine value here, which is 7.5, right? We have our k value. So now we have everything that we need to write both the functions. So I'm going to write cosine. So we have a is equal to 2, k is equal to 36, c is equal to positive 1, and then d cos is 0, so I'm just not even going to write anything in. So it's going to be y equals 2, right? Because I'm just doing a cosine bracket 36 x, because I don't have a d value, plus 1. And that is my cosine function. On the flip side now, let's do the sine function is going to be y equals 2 should be sine. 2 sine, same k value, but now I have that shift, right? Minus 7.5, close, plus 1. And that is going to be my sine function. These are the same thing. They're going to have the same graph. It's just when we talk about why this is in applications, right, one represents a different type of displacement than the other one does. Okay, so I want you to try doing BC on your own and try doing example 2 and 3 on your own. So pause the video here, try the rest of the lesson on your own. I'm going to take it up for you in the video, right? But we will come back and watch this, or we'll come back and try doing some of these in class on the next time I see you as well, so tomorrow. Okay, so I'm just gonna go here, right? And we're just gonna go here and start with our AKCD values, our AKC values, and then we'll deal with our D, right? So this one, the first thing we want to figure out is obviously what the amplitude is. So I'm just going to go ahead and say max. Max is up here. I don't like that max because I actually don't know what it is. So I always like to pick a number where like it's very obvious. So I'm going to pick this one right here. Pick 120, and I'm going to follow this graph through, right? Still not working. So let's figure out two numbers where it's very obvious what our max is, right? So I'm going to start off with, it's very obvious that it's 5 here, right? It's very obvious that it's 1 here. So I'm going to do 5 minus 1, right, divided by 2 is equal to 2. Okay, so that's my A value. My A value is 2. I'm just going to highlight it. Then I'm going to go find my axis, right? So my axis is just max 5 minus 2, which is 3, right? So my axis is going to be here, right? And now I'm going to go look, what is the closest value that I can start with? And I might be tempted to start here and draw the sine function, but this one is not exactly on 30, right? So let's start somewhere else. Let's start somewhere where it's blatantly obvious. Like this one's right on 120. So I'm going to do these and this one. This one might be right on 30, but when we come here, it ends at 120, I guess you could say. But I like this one over here better, right? Just depends on what you think is nicer. So I'm going to start here, go up to 210. So I start at... So I start here at 120, follow the graph all the way up to about 180. Sorry, 210. So 120, 210 minus 120 is going to give me about a period of 45, what I said, right? Or 90, sorry, 210 minus 120 is going to give me a period of 90 degrees, right? So if I'm going to go find my K value, I'm going to do K is equal to 360 divided by 90, which is going to give me 4, okay? So now I have my K value, which is 4. So I have my A, C, K. I'm going to go find my D value, right? So my D value, I know I'm going to have a D cos, and I'm going to have a D sine. Let's do our D sine first because the sine function is like blatantly obvious, right? So it starts, we'll say it starts here at 30, right? So 30 D sine, right? D sine, and then our distance from the cos is right here, d cos, right? So d cos is a little bit hard because it's like somewhere in between 60. It's just a little bit less than 60, so we can't assume it yet. So let's just deal with sine first. So our sine function, it's obviously 30, right? It's like right on the dot. So d sine is plus 30 degrees, right? So if we write out our sine function, it's going to be y equals 2 sine x, sine 4x minus 30, because you have to change the sign, right? Plus 3, because that's our axis, right? So now to deal with our d cos, right? I know that between this point and this point, there is 90 degrees. And I know the graph itself turns every 4, right? So every time we go up by a certain number. And if you look at the certain number we're going up by, it's called our interval. And like you'll notice, even on a graph, we go up by a certain interval each time, right? So think about it this way. The interval here is going to be whatever our period is divided by the 4 intervals that we have. So our period was 90 divided by 4, right? So that's how we're going to get our cos. So it's going to be 30, right? 30, and then we're adding the interval. So 30 plus interval, which is going to be period divided by 4, which is going to be 90 divided by 4, which is like 22.5, right? So our d cos is going to be 52.5, which makes sense because it's just a little bit less than sine. So y equals 2 cos, everything else stays the same, 4x minus 52.5 instead of 30 plus 3. Okay, so that's how you solve that one. I'll let you try this one. Now pause. If you still aren't getting it, try C on your own, right? And that way we can take it up together after you unpause this video. Okay. So C is a little bit more tricky because we have a lot more stuff going on here, right? So again, we're just going to do the same thing. We're going to first go find our amplitude. So A is equal to max minus min divided by 2, right? So let's go to this graph and find our max point. Max is here, our min is here. So we have a max at 3 and a min at -5, right? So A is equal to 3 minus -5 divided by 2 is equal to 4, right? Then we're going to go find our C value, which is just going to be the max minus the amplitude, which is going to give me -1. And I always like to go just draw in my axis because it helps me visualize the graph better, right? So then I go and ask myself, okay, what's closer to the x-axis, cosine or sine, right? And if I really, really think about it, here's this max closer to the x-axis than this min or this axis point here. So here our cosine function is actually shifted to the left, right? So I look at it, shifted to the left. So I'm going to deal with this cosine function here. Okay, so that's going to be important when we do our d. So I'm going to write this as my d cos. And then if I look for my sine function is going to start at the 60 degrees right here, go down, and go up. So this is going to be my d60. Okay. So now let's just go deal with my sine function. If I look at my cosine function, if I look at my cosine function, right? Or let's just look at our sine function because it's the same thing. But the point, I'm just going to look at this rotation of cosine, right here. The point from here to here is going to be about 120. So I just did 220-ish minus 90, right? Or whatever these two are. And then I got 120. Okay? Or I could have done 180 minus 60, also would have gotten 120. Okay, so my K is going to be 360 divided by 120, which is going to give me 3. So my K value is 3. And then I know that my D cos is going to be a shift this way, right, by one interval. And we know that one interval is 120 divided by 4, so 30. So we're going to shift this way by 30. So it's going to be minus 30. And my D sine is going to be plus 60, right, because we're starting at the 60 point. So D cos is negative 30. D sine is positive 60, right? So we have y equals my 4 cosine 3x plus 30, because we changed the sign when we put it back in, minus 1, right? And the other one's going to be y equals 4 sine 3x plus minus 60, because you move to the right now, minus 1. And those are two functions. Okay? So last thing that we're going to do is we're actually going to be drawing, I'm going to be drawing both example 2 and example 3. Now, instead of being given a graph, we're actually just given information properties about this graph, right? So we actually have to make the graph from scratch. So this is one of those times where, like, remember I said that the amplitude max plus min won't always work. This is one of those situations. So we have an amplitude of 3. So we know our A value is going to be 3. We have a period of 180 degrees, right? So we can find our K value because it's just 360 divided by 180, which is going to give us 2. And a max point of 0.5, right? Represent the function with an equation in two ways. So this is where if we're given a max point and we're given the amplitude, we can find the axis. And then that way we can find our min point too, right? So max point minus the amplitude. So we're going to do 5 minus 3 equals axis, right? Which is going to be 5 minus 3 is 2 is equal to your axis, right? So your axis is going to be here. And we're going to exploit that property where the amplitude is both one way up is going to be, did I do this right? 5 minus 3 is 2. Yeah, 5 minus 3 is 2. Right? We know that both ways up and down have the same amplitude. So then our min point is going to be somewhere down here at 1, 2, 3 at -1. Okay? And because we're starting at a max, we know that this must be a cosine function with no shift right now, right? So I'm just going to go, and I know that since the period is 180, the intervals, there's going to be 180 divided by 4. So each interval will be 45 degrees. So I'm going to go 0 to 45 is going to be at the axis. Then we're going to go down to 90, it's going to be at -1. Then we're going to go back to between 90 and 180. It's going to be here. Then we're going to go up to 180. It's going to be at the max. So that's one full rotation of cosine, right? Then I'm going to do the same thing. I'm going to go, okay, plus 45 here, plus 45 here, plus 45 here, plus 45 here, right? Because it's just a repetition of the same x and the same y's over the same x interval. So the only thing I'm really worried about is x. So I'm going to go minus 45 here, 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 and then minus 45, and then minus 45. And then I'm just going to go ahead and connect all of these together. Okay, and now I have my cosine function. And it says represent the equation in two different ways. So we want to write it as a sine function and as a cosine function. Obviously, the d cos is right here, so it's easier to write this originally as a cosine function and then deal with the shifts after, right? So let's write this as a cosine function. We have our a, k, c, and d values. So our d is 0, our c is 2, Our k is 2 as well, right? And our a was 3. So we're going to write it as y equals 3 cosine 2x plus 3, right? And the reason I'm not writing anything in brackets in the middle is because I don't have any horizontal shift. But I do have a horizontal shift with sine. So if I go back here, I'll see that my sine function, the closest start point to the y-axis is here. So I actually shifted it to the left by 45 degrees, right? So then it's going to be y equals 3 sine 2x plus 45 plus 3. And that's going to be my final answer. So now I've written this in 2 different ways. Okay? So try example 3 on your own and actually submit this as an exit ticket today to Google Classroom. I will post the Dropbox for you to post this on. I want to see everyone at least try it on their own one time. Okay? And that's it for this lesson.